Hello everyone, I hope you're having a nice Saturday. As I promised yesterday, I wanted to do the review sheet, and I thought I would just make it as part of a screencast so I can talk about it as I write. So the first thing I'm going to want you to know is how to solve a Fermi problem. And let's make sure with those that you have pay attention to the units and make good assumptions. I think you're getting pretty good at those already, so let me know if you have questions. Second thing is uncertainty. And that includes calculating uncertainty. So that's an uncertainty if you're using the, let's see, the measuring device, or so that would be where it's plus or minus half the smallest division. Or it could be an example where you're calculating uncertainty. Sorry about this boldface. Calculating uncertainty from measured quantities. And the examples I'd send you to are the ones where we looked at calculating the uncertainty in area, given measurements of radius, or velocity, given measurements of distance and time. In addition to that, on uncertainty, you should look at how to estimate uncertainty. So that's these ballpark figures, like when you're trying to measure, for example, the length that the coffee filter falls between two cards, or if I hold something above the ground, measuring it with a ruler, you can't do that to the nearest half a smallest division. That's only the best possible uncertainty for a particular measuring device. So when you consider things like reaction time or reasonable estimates, you need to look at ways of reducing uncertainty, such as repeated values, that sort of thing, repeated measurements, and classifying uncertainty. By that I mean, is it systematic or random? So you need to know which is which, what causes which, and if you look at data, can you say that certain data is illustrative of random or systematic uncertainty, or both? Next, we have motion diagrams, and that's displacement, velocity, and acceleration. Now, I am not going to ask you anything about speed versus velocity. I always mean velocity for your test. It's just the textbook has it in there, and maybe for the SAT too, if you want to take that. But for this course, it's just displacement, velocity, and acceleration. And the particular cases that I want you to study is how to draw each of these graphs for constant velocity, constant acceleration, and free fall. And with regard to that, make sure that you keep track of the sign. So make sure that you know what negative means. It doesn't mean necessarily that it's getting smaller. It might mean that it's getting bigger, but in a negative direction. So we've got one-dimensional quantities, and if it's one-dimensional, it can be forwards or backwards, and one is positive and one is negative. Then we move to free fall and hang time. So I want you to know the principles of each and how to calculate answers to problems. With regard to problems, you could know something about distance, displacement, final velocity, time of flight, that sort of thing. There's two equations that you need. I'll just put them here. They'll be on your test as well, though. So I don't request anybody to memorize the equations. First of all, distance equals 1/2 AT squared. And acceleration is equal to v final minus v initial divided by time. And of course, g, this universal acceleration, is 9.8 meters per second squared. I think that's enough for a good test. Don't you? Email me if you have questions. Have a good weekend.